Hi, this is Mr. Estrada. In this video, we are going to go over problem 32 from the August 2012 geometry Regents. The coordinates of the endpoints of FG are -4, 3, and 2, 5. Find the length of FG in simplest radical form. So one approach for this is to use the distance formula as you see it here. This is a formula that's not given to you in the back of the Regents on the reference sheet. You have to memorize this formula if you want to use this approach. Later on, I'm going to show you another approach where you don't use the formula as you see it here, and you don't have to worry about memorizing the formula. But for now, I'm going to show you how to solve this using the distance formula. So I'm going to go ahead and label my points x, y, x, y. You're all familiar with that. And since this is just my first set of coordinates, I'm going to label it x1, y1. Whoops, that's supposed to say x1, y1. And I'm going to label the other one x2, y2. Now I'm going to substitute for x2, for x1, for y2, for y1, and this is what I get. Let me just point something out real quick in passing. It's very important that you acknowledge that you have a subtraction sign here, and you also have the negative sign that's going to come with that 4. Alright, you're not going to discard that negative sign. It has to come with the number because it's a part of it. So you're going to write 2 minus -4. Okay? Okay, now you're just going to simplify this step by step, starting with inside the parentheses 2 minus -4. That's going to give you 6, so you get 6 squared here. 5 minus 3 is 2, so you get 2 squared there. 6 squared is 36, 2 squared is 4, 36 plus 4 is 40, so you get d equals radical 40. Now, because we have to put this in simplest radical form, we have to break this down. Now, how do we do that? The way that I do it is I use the largest perfect square that's going to go into the number under the radical. In this case, that's going to be 4. So I can rewrite radical 40 as radical 4 times radical 10. So let me explain what I'm doing here. Alright? What you're doing is you want to find the largest perfect square that's going to go into that 40. That's 4. Now you need another number here that's going to multiply with the 4 to give you 40. This number here does not have to be a perfect square, so it's going to be radical 4 times radical 10. You can't break that radical 10 down any further, so you're just left with 2 radical 10. And that's the answer in simplest radical form. And just in case you're wondering why you cannot break down that radical 10, the reason is because you can't find a perfect square that's going to go into 10. Okay, now let me show you a different approach to finding the distance. One thing you can do is plot the coordinates in a Cartesian plane. So in this case it's -4, 3, and 2, 5. And what you're going to do is connect the coordinates and you get this line here. You got F, G. Now what you want to do is form a right triangle, and you're going to see y you form a right triangle in a second. What I want to just go over briefly is you make sure that one of the legs is parallel to the x-axis and one of the legs is parallel to the y-axis. That's going to ensure that you have a right triangle. Okay, now the reason you're going to form a right triangle is because now you can use Pythagorean theorem to find FG. I'm going to make this C because that's the hypotenuse. So the distance here is 6. The distance here is 2. Now you can use Pythagorean theorem to solve for C. So that's going to be 6 squared plus 2 squared equals C squared. 6 squared is 36. 2 squared is 4. 36 plus 4 equals 40. 40 equals C squared. Square root both sides, you get radical 40, and then you're going to break down the radical 40 with radical 4 times radical 10, and you get 2 radical 10. So this is another way to do it in case you forgot the distance formula the day of the test because you're so nervous or whatever. Okay, thank you for your time. I hope that was helpful. Take care.